Alright, so in the last video, we started looking at how Euler-Bernoulli beam theory and beams in general are applied in designing and building barbecue grills to make them more stiff, while at the same time using a minimum additional amount of material that would make the barbecue grill heavy or would increase the cost to build the barbecue grill. So a lot of what I've talked about so far, like I said, anybody with a background in an engineering, solid mechanics, strength of materials type class probably would be able to pick those things out. So this is where I think the presentation will start to get more interesting, because I'm going to start pointing out things that I don't believe people would see even with those backgrounds, unless they kind of had a trained eye and were used to designing these sorts of things. So let's go ahead and get started. Let's look at this barbecue grill again. If we look at the lid, you'll notice your barbecue grill lid, if you were to push on the edge of the barbecue grill, if you push in like this, you'll find that it's pretty stiff. It doesn't deflect in very easily. It really isn't perceptible at all. But if you remember back to the first presentation, or was it the second? Well, when I showed some relatively thin sheet metal, it deflected under its own weight quite easily. And so the question is, why doesn't the barbecue grill deflect in when you start applying a little bit of load by like leaning on the barbecue grill or pressing in on its side? And so what I want to call your attention to is kind of this lip or bevel or edge that's kind of rolled into the edge of the lid of the barbecue grill, and you can see it on the top here and on the bottom part of the grill as well here. So let's kind of zoom into that a little bit more closely. So you see there's this edge right here, and what ends up happening is it's kind of like you're adding a beam, you're wrapping a beam around the edge of this barbecue grill, and if you go and you try to push on this beam, it's going to have a high area moment of inertia in this direction, and it's going to be very hard to bend this in. And this is kind of a really slick trick that engineers use to significantly stiffen up the barbecue grill. It also helps maintain the torsional stiffness of the barbecue grill. So I really like this, and you can see similar things to this if you look at hot rods, for instance. They'll build various beading tools to do put edges in the ends of panels like this, and that'll help significantly stiffen a panel up for minimal additional weight. Let's see, so let's go to the next slide. So to give you some demonstration so you can see kind of how this principle works, I wanted to come up with something simple that you could try at home. If you get a pop can, this is a very thin aluminum, and you cut it in half like this, and then you try to compress it like this, you're going to find that it's very easy to compress that pop can. Okay? And this is kind of like the barbecue grill. If that lip wasn't there, it would compress in quite easily like this. And to demonstrate the lip, what I did was I took the other end of the pop can and I cut out the inside. So this is kind of like the base of the pop can, and the base of the pop can kind of has a smaller diameter circle, and then it has this kind of lip that goes inside. So I cut out that inside material totally. And then I got my fingers and I put them on the outside edge here, and I try to squeeze in with my fingers. And if you try to do this, you're going to find that it's very difficult to squeeze in that pop can. And the reason is you have this lip right here that's acting like a beam kind of wrapped around the interior circumference of this pop can. And so we've taken out a lot of the material that was here on the inside, but still we get significant stiffness, and you won't notice much just with your fingers that the pop can has lost a lot of material. It's still pretty stiff. So let's see, let's go. So interestingly, it turns out this idea works in reverse as well. So this is kind of like the pop can idea. If you look at the barbecue grill, if you look at the bottom under where these propane distributing elements are. You can see there's a hole. Okay, here's the hole from the bottom of the grill. It's a pretty big hole. And a hole like this, typically, if you were to press in on this hole, the material surrounding this hole, it might try to deflect in fairly easily. But if you look carefully, they've built this lip around the edge of the hole. And it's the same thing. It's kind of like they build in an I-beam or a little beam, high area moment of inertia beam around the edge of the hole. And the effect of that is it's very difficult to push in on that material. Otherwise, it might, if that lip wasn't there, this would probably be very easy to push in. And as a result, you probably think you have a low quality barbecue grill. People's perception of things when they're kind of floppy is that it's low quality, so you don't want to have that sort of thing going on. It also is kind of nice because it really makes the barbecue grill more beautiful when you put in these lips. So it makes it look more beautiful, and it makes it look higher quality, and it's really low cost. You'll see similar things in certain aircraft construction if you look at how the inside of airplane wings and ribs are built. So this principle is really important when you need to put a pass-through in a structural shell. So this is the carbon fiber monocoque of our race car, and you can see we had all these suspension links, and they had to go through the carbon fiber monocoque into the various loading points of the rack and pinion. And so the problem is when you put a hole in a monocoque like this, that can cause it to seriously lose a lot of its stiffness. So what we do is we apply these same kinds of principles. In the case of a carbon fiber monocoque, you're also really concerned about torsional stiffness. And the reason being, you want to make sure that your suspension points maintain their same position relative to each other as the race car is driving around the track. And if you have holes in your this is basically your torsional structure, your torsional load-bearing member, that's going to significantly reduce your torsional stiffness. So you've got to do something to reduce that effect. And so if you look, this is what an example of what you can do. So this is the anti-roll bar for our race car, and you can see it has to pass through the top of the monocoque. And this is what it looks like from the inside, and you can see we've made this carbon fiber kind of lip that we bond in with epoxy. And so by putting in these kinds of additional lips, we can significantly minimize the amount of reduction in stiffness that the monocoque experiences, even though we have to put holes in the monocoque for our various structural members. So this is one of the really the most interesting principles that you learn when you look at the barbecue grill, and you can see how it's applied to the race cars. And so in the next presentation, I'm just going to wrap things up and point out a few little odd things about cooking on the barbecue grill. So thank you.